Authentication. You need to provide strong identification of the users. If there's any holes at all within the authentication mechanism, the entire application is vulnerable. Data formatting and protocol parsing. What this covers is what is it that handles input from the users or from the network, and do the components that handle those parts of the application have the security put into them to meet the challenge of dealing with that input. Is it secure, or could somebody put in 1025 characters into what was designed as a 1K buffer? Sandboxes. If an application uses a sandbox of any kind, assumption number one is that anything going on in the sandbox is deemed unsecure. Assumption number two, and the one that you need to test and be indubitable of, is that anything going on in the sandbox cannot escape the sandbox. Classic example of that is Microsoft's JVM. Back when they first came out with it, it seemed as if every 2 weeks they were coming up with some new way of breaking out of the sandbox that the JVM provided. Skipped one. Permissions. Pretty straightforward. Granting or denying a user privileges within a system. If you got to be sure that your permissions are strongly enforced and that they're done in a secure fashion. Session management. You need to make sure that the session management is every bit as secure as your initial user authentication. If the session management system is vulnerable to any sort of replay attack or any other kind of hijacking, then you've essentially invalidated your authentication system, because a user can impersonate any other user. State machines. The state machines are, an example of a state machine is requiring a user to log on prior to accessing an application. If your state machine is vulnerable and subject to manipulation, the example that I gave, you could access the application without having first logged on to the system. Obviously, state machine is something that you need to be sure is secure. Additional things to making the threat modeling process as effective as possible. Clearly defining roles and responsibilities. This is important on two fronts. By ensuring that the roles and responsibilities are clearly defined, you eliminate any potential of turf wars between this is my job, and having unproductive efforts because of that. What you also eliminate is the risk that things will be done multiple times by different people to different standards. By having the roles and responsibilities clearly outlined, it provides the structure necessary to carry it out effectively. Determining which applications to model. Threat modeling is a good tool, but not all applications need to have threat modeling applied to them. Small internal applications that deal with no sensitive information and not part of a business critical infrastructure, that's not something that you necessarily need to put the full security process to. Anything that deals with the public or has remote anonymous users or encompasses functionality that is business critical, those are the things that you need to look at and that you need to ensure that the security is very strong on. You need to know whether you're modeling a server or a client-based application. The simplest way of explaining the difference is that a server-based application is something like a web server and a site contained on that web server. Client-based application is something like, we'll throw out Word as an example, your word processor. Your client application requires the user to take action, to make an active take an active role in any sort of risk that may be there. Something like the bazillion worms or bazillion Trojans out there that that mass email everybody in your contact list and send them to everybody there. Typically those take a user action, opening an attachment. One of the things to consider in looking at a client-based threat model is that there are some things that users can, and unfortunately will, do that make things inherently unsecure. You need to make sure that you recognize any such behavior as being out of bounds for the threat model. There's only so much that you can control. You hand somebody a knife, most people aren't going to stab themselves, but somebody might try, and you've got to say it's not your fault. Even if you are dealing with client-based things, you can't protect users from their own actions. But by the same token, you do have a responsibility to protect users from the actions of others. An example would be the Office document macro viruses that were all the rage a couple of years ago. They operated, they were successful because when a user opened a document, arbitrary code was executed. To mitigate that vulnerability, what Microsoft did was create trust levels as far as code goes. And if a document has a macro in it, you will be warned, hey, this document has a macro. Do you really want to execute this? Unfortunately, some users think that's okay, but that's one case where the risk was addressed. Basically, the client app was doing something that it shouldn't have been allowed to do. In order to consider a threat model complete, it needs to resolve all threats. Resolving a threat does not necessarily mean that it has been sealed off or fixed. It simply means that it has been acknowledged. Some vulnerabilities are not critical enough to be closed or do not have enough of an impact if they are exploited. They're not closed, but they are resolved. They're basically accepted. If a threat is unresolved, then the security of a system can't be quantified. As I've said before, threat modeling relies on allows for the quantification of the security of a system. If a threat has not been fully explored and acknowledged, then the threat model is not complete and the security is not quantifiable. Reviewing the threat model. A threat model, like anything else, is best accepted once it's been reviewed by peers. Having co-workers or other people involved in your industry review the threat model allows you to take their comments into consideration and use that for further refining the model itself. Additional outputs of reviewing the threat model include ensuring that the model is consistent. If you've chosen to implement a feature level model, having your threat model reviewed allows you to ensure that you've maintained a consistent focus, a consistent level of detail throughout the document. That's not to say that you can't put more detail into your high-risk areas of the application, but it is to say that you've been consistent throughout in looking at everything. It also ensures quality of the threat model itself and provides feedback to the team that created the threat model. We learn by doing and receiving feedback from those things that we do. That's what allows us to create better stuff. Anytime that functionality is added, changed, or removed, you need to go back and revisit your threat model. Anytime that any of your inputs change, you have to go back and revisit your threat model. A threat model is not a deliverable of a project and it's done. A threat model is and should be a living document that changes over time as the application changes. It should be considered an integral part of the application's documentation. How to make it work? Well, you got some practical considerations to take into account. You need to plan, document, schedule, and determine. Planning means dedicating time to the threat modeling process in the project's life cycle. Just like any other task within a project, threat modeling is something that needs to have time allocated to it. Time and resources allocated to it as part of the project plan. Threat models can be used to design the security test plans. That's where the testers, that's where the output of the threat modeling team is used by the testers to create the condition checks to make sure that